Cheers, Trish.
Today, my name is Aaron. I'm coming at you live from Singapore.
Good morning, good afternoon, and good evening to
Chips for everybody.
Chips for everybody. Yes, that would be an FYI.
We have Oleg and Mark. How's it going? Welcome to the stream and thanks for joining us.
I'm in San Francisco Bay Area, a little less snow than you guys think up.
How's it going, Tommy?
Hey guys, how are you?
Speaker? Daniel? Daniel, how's it going?
Hi, good, thanks.
Azure function is just an entry point to Good morning, good afternoon, and good evening to anyone who's watching us live on YouTube and Twitter. Thanks for joining us for yet another Solace Community Live event. This is one of the very exciting events that we're hosting today. It's near and dear to my heart because we ran a Solace Community Lightning Talks last year, and it was a huge success. We had a lot of people talking about different things, which was pretty cool. Today's event is particularly interesting because we have different speakers, 4 different speakers from our developer community who are going to be talking about very cool technologies and projects and products and tools that they're using in the EDA world, event-driven architectures. So some of them are using Solace PubSub Plus, integrating it with different tools and products, and others are talking about just in general event-driven architectures. So before we get started, a couple of house rules. So let's, for everyone who's joining us right now, we have a couple people on YouTube and Twitter. Let us know where you're joining us from. I would love to know where people are joining us from. It's different people around the world, different time zones. So let us know what country, city, state you're joining us from. I am currently in Canada, Vancouver, and it's a bit sunny today, which is nice. Not the usual Vancouver atmosphere. It's usually raining or cloudy, but today is a good day for the Solace Lightning Talks. So as people are trickling in, I see people are joining us. Some people are joining us from India. This is great. We have Poland, Varsova. Manish, welcome to the stream. We have a couple people here. People joining us from Orlando, Florida. We have Mark behind the scenes watching the comments from the Solace Devs Twitter account, joining us from Orlando. Other people are joining us from India. So this is great. We have a couple people from around the world. That's awesome. I want to remind everyone that this is a live event. This is a live event. What does this mean? This means that we are accepting questions from the audience. So if you have any questions throughout the event, whether now or like when I ask them in advance, or for the speakers, whether it's from me, for anyone else, please feel free to ask them in the chat. This is meant to be a very interactive event where we get to interact with our speakers and ask them very tough questions. So if you have any questions, feel free to ask them to the speakers. As we continue and start talking about the different talks for today, we will be giving out some swag to an audience member. So anyone from the audience who's continuously active, feel free to ask questions. We'll be giving out swag to some audience members. And another thing I wanted to say is we have our Solace community on solace.community. That's pretty easy to remember. Feel free to join the Solace community. It is a very inclusive and friendly community where a lot of people ask questions about Solace, about event-driven architectures, or about different tools and integrations. Feel free to join and yeah, interact with us. So I see people are joining us on different platforms, and questions are starting to get in, which is good. So I want to introduce, to give you a quick overview on what we have for today. So for today, we have a very cool agenda. We have people joining us from different companies. The first speaker, we're going to kickstart the talks for today with Sjaak. Sjaak will be talking about the integrating the Solace PubSub Plus connector with Boomi. He has a very cool demo use case with architectural diagrams on how you can bring in event-driven architectures into your iPaaS world, which I'm super excited to listen to Sjaak and check out his demo. Then followed by Laurent from Microcks, where he'll be talking about accelerating event-driven architecture adoption with Microcks, with mocking and testing your event-driven APIs. So that's going to be a cool talk. And then we have Dunith from WSO2. He'll be talking about how what the role of WSO2 in EDA. And then lastly, we are wrapping up the lightning talks with Ahmed and Dennis, who will be talking about event-driven autoscaling on Kubernetes using KEDA. So again, throughout the whole talk, feel free to ask your questions, and we'll get ready to talk about it. So without further ado, let's see who's coming in. We have people coming in from India, from France. That's awesome. Keep them coming, you guys. That is great. So let's go ahead and kickstart the Solace Lightning Talks. As always, remember, if you have any questions, feel free to ask them in the chat window, and then we can answer your questions, whether now live on the stream or on the Solace community, if you go ahead and register at solace.community. All right, so you have an idea on what the schedule is like, and let's go ahead and kickstart the talks for today. I would like to introduce to the stage Sjaak. He is the co-founder and CTO of Appronto, and today he's going to be talking about bringing EDA to the iPaaS world using Solace PubSub Plus and the Boomi connector. So let's bring Sjaak to the stage. Sjaak, welcome to the stage.
Hi.
How are you?
Yes, I'm good. Thank you. And you?
That's great. I'm doing well. Thanks. I'm super excited for today's talk, and particularly to see what you're going to be talking about. Before we get started, where are you joining us from, Sjaak?
Yeah, we are located in the Netherlands, in Breda to be precise. So the Netherlands is in Europe, very nice country. And yeah, we do a lot of EDA stuff every day. So
right. That's great. Today, you mentioned, or I mentioned that you'll be talking about EDA and the Solace PubSub Plus connector and Boomi. So can you give us a bit of background about what you're going to be talking about, and then we'll jump into your slides, and then we'll jump into your demo after.
Sure. Yeah, I'm prepared a few slides just to let's say introduce you to how we use Boomi and how you can use Boomi in combination with Solace. As an event broker, in combination with the native Boomi PubSub Plus connector, and show you some nice features of it. Okay,
perfect. Do you have your slides, or do you want me to share your slides? I can share my screen. I have them ready if you want.
Yes.
Awesome. Okay.
Please share. That's fine.
Perfect. Let's go ahead and do that. All right.
All right.
So, Jack, the stage is yours. Go ahead.
All right. Thank you. Well, welcome all. I'm going to tell you something about Boomi and Solace. Let me first quickly introduce myself. So I'm Sjaak overal. I am a CTO at Appronto, and I in the IT business since 1992. So quite a track record. I've done many different things. Sysadmin stuff, development stuff, but also I've been, let's say, last 10, 15 years tech lead in many different projects and areas, including integration. And integration is actually my main focus since, I guess, about 15 years. With different technologies, actually. So I've done Red Hat JBoss Shoes. So we have done Oracle, Fusion middleware stuff. And more recently, the last 6 years, Boomi in combination with Solace. All right, about Appronto and what we do. We do Boomi. That is our main focus in combination with Mendix as an application development. We are only going to talk about the Boomi part in combination with Solace, and we are a Solace partner since 2020. So about a year. I guess we have 100+ customers and about 35 employees. Mainly developers. All right. So I'm going to tell you something about the great combination of Boomi and Solace and why it's so good. So let me first tell you why we choose Solace. About 2 years ago, 1 year to 2 years ago. And we were actually looking for a better event broker for the Boomi platform. And we did quite some research. We looked at different, let's say, competitor products. ActiveMQ was one of them. I'm quite experienced with that platform as well from the past. But we looked something more flexible, better scalable, and also, let's say, easier to use. And we figured out that Solace was actually working on a native connector for a Boomi platform. I met some Solace guys, I guess, 2 years ago, 3 years ago at Boomi World. I think in Las Vegas and later on in Washington. And we had some chats, and we actually joined their beta program back then, and did some testing. And we are actually quite happy with the Solace connector because it offers you extra features on the Boomi platform, like dynamic topic structures and wildcards, like better platform connectivity, for example, to more custom-oriented landscapes, because you can connect anything with Solace, whatever you like, not just Boomi, but of course a lot of other connectors are available. It's multi-cloud, and it's ease of use in combination with the Boomi platform. So let me give you a couple of examples. So this is one of the architectural overviews Solace uses, and we use it as well. So for us, if we look at use cases, we can use Solace, let's say in a classic ERP world. We are doing quite a lot of ERP implementations, upgrades from an integration perspective. But we were lacking, for example, in the IoT area. So our older, let's say, previous platform was not capable of handling IoT data. With Solace, we can, because it natively supports MQTT. And since we can integrate in a, let's say, high-performant way with the Solace platform, that gives us a lot more opportunities in that area, in that space as well for the upcoming years. I think one other important thing is that you can run Solace anywhere. You know, it's multi-cloud. You can run it in your own AWS environment, like we do. We host a lot of stuff for customers. So it's it gives you a lot of flexibility and also scalability options. And
it's pretty neat to see the use cases of the multi-protocol and the multi-cloud powers of the Solace Plus platform, and seeing kind of like an architecture diagram on how it's being used.
Yeah, I think on the next slide you can even see a more, let's say, specific example of stuff we do. This is an example reference architecture. On the left side, you see some IoT locations, let's say manufacturing sites where we collect IoT data. And we have the option to use, let's say, a combination of both a Boomi agent and a Solace agent to collect the data, perhaps already aggregate some data, and then push it to the Solace backend in the middle, so which is our core of the platform.
Nice.
In combination with a bigger and better scalable Boomi runtime. And on the right side, you see, let's say, the applications which are using, let's say, aggregated parts of all that data. Depending on, let's say, the use case. So that goes from data warehouse platforms and solutions to, let's say, custom application we built with the Mendix platform, or just classic ERP with logistical processes and manufacturing stuff. So everything is possible.
Here basically you're leveraging the iPaaS feature of Boomi, where there's kind of all of these different integrations that as soon as you're in the Boomi platform, you're exposed to all these different integrations that Boomi supports. And then with Solace, you're kind of like activating the real-time streaming of data from your different edge sources, also leveraging the kind of the multi-protocol translation within the Solace PubSub Plus platform.
Correct. It's about liberating data and platforms and connecting all together. Yeah.
Right. Cool.
Yeah. Cool. So let's talk about the PubSub Plus connector for Boomi itself. So, like I said, it's a native connector, which means it has the same look and feel as any Boomi connector, and it just pops up as a green icon on your screen. What you are looking at is the developer module of the Boomi platform. It's low code, which means all based on building blocks. It's running from your browser. You don't need any Eclipse or local components to build your integration processes. And the connector now supports even more use cases than in the past. Initially, I think about a year ago, it only supported get and send actions. Now you can, in combination with listen, they added the acknowledge, the ACK, and the request option as well more recently. So that's how it looks, let's say, from the front end. If we go to the next slide, you will then see, let's say, the properties you can set. So from a mode perspective, Boomi does support direct, persistent, non-transacted, and transactant options. And you can, let's say, generate, and that's the nice feature on the bottom, the option, the checkbox you see there, create queue and topic subscriptions. So it even means that from a Boomi perspective, the developer can just configure the connector, and Boomi will generate under the hood, let's say, the queue and topic subscriptions on the Solace side automatically. So that means even for us, Solace is a kind of low code, or actually no code in this case.
Right. So you can do like the configuration as well on the broker directly from the Solace connector on the Boomi platform. So like what you see here, correct me if I'm wrong, Sjaak, is kind of all the different properties and configurations you can do in the Solace connector on the Boomi canvas. And then one of the things that you just showed here, that it's not just connecting to the Solace PubSub Plus broker, but also you can add more configurations. So let's say if you have a use case that requires persistent messaging and you want to create a queue on the broker, all you need to do is just check that box. And behind the scenes, the Solace connector using the Solace APIs will create a queue on the broker.
Correct, 100% correct. Yeah, and other than that, you can configure parameters like the number of concurrent executions. So let's say parallelism is, of course, also supported. Yeah.
Nice.
Yeah. Right. Then let's say some neat features they have been adding, I think as of the first version already. So inside Boomi, you can use properties to dynamically generate your topic. Let's say, for example, so one of the most important things with any Solace project is, of course, let's say, making design decisions regarding your topic taxonomy, your structure, the way it looks like. So once you have that in place, you can dynamically set your topic from the Boomi canvas and go from there. And you can use any, and you see an example of that, many different kind of properties, let's say, to set those parameters for your Solace connection. So sender IDs or application message IDs can be set dynamically based on payloads you have or anything else. You can even do connector calls to an external platform just to look up stuff and to use it to set your Solace connector. So there is a lot of things you can do. In this case, you see a JSON profile. So actually from an OData, I think it was a Navision, Microsoft Navision OData web service we used here to set the application ID dynamically.
That's neat. And yeah, that's one of the things I really like from a Boomi perspective is whatever data or interaction you had in previous steps or shapes, you can propagate it to other shapes. So now you're setting, for example, some Solace property based on, you mentioned here, for example, a JSON profile that you got from an OData client that you got previously from the previous connection.
Yes, yes,
cool.
That's correct.
Awesome.
And then I think regardless of the connector, Boomi always looks the same. So you interact in the same way as you do with other connectors for other platforms. No, so it doesn't even matter which broker, let's say, you would use. It all looks the same. So that makes it very easy for the developer to implement Solace into your platform. Yeah, on the other side, if you look, this is actually a sub-process. So it's a generic sub-process we can reuse for any integration process. And why it's generic? Because we send, let's say, we set Solace properties, as you saw on the previous page, and you can set stuff dynamically. So including the error handling, and what you look at here is what we call a process route inside Boomi. So the error handling of the feedback we get from the Solace platform is handled by a separate deployed component, the error handler specifically for Solace. So that's even more interesting. So for example, if you want to enhance your error handler for your Solace process, then you can simply change the error handler, deploy it separately. There's no need to change the calling integration process in that case. All right, just another example. Let's say, how can you? That's at least one option to deal with retrying messages from a Boomi perspective. What we do is you can simply create a process to get some messages from a dead message queue. The way we use Solace is that we have a dead message queue for basically any integration process we have. We also try to separate, let's say, queues from each other. So we use only one payload schema per queue. So that means we also have one dead message queue per process, at least from a listener point of view. And in this case, this process can simply retrieve messages from the backend and then push the message to the original queue, and they will be automatically picked up by a Boomi listener again. And that's, I think, a nice summary of how Boomi looks from a developer point of view, and how easy it is to integrate Solace and add it to your iPaaS Boomi platform, and just connect any backend system you need to integrate with a very powerful message broker with all the features which come with the Solace platform.
Right.
And that makes us happy and the customer as well. So
nice. No, thanks. That is great for sure. I was particularly I was very happy to see kind of like all the different use cases that you do with this. Particularly, I'm also like I was very interested and with the architecture diagram for like how you guys use it at Appronto from that perspective, which is great. I do have a couple questions for you, Sjaak, particularly kind of from your implementation and usage of the Solace connector on the Boomi platform. What are the challenges that kind of you passed or you solved using the Solace PubSub Plus connector in the Boomi platform?
Yeah, I think some of the challenges initially was the way we had to deal with dead message queues. So that is, and also I think, dead message queues are, for example, not easily manageable from a Solace perspective. So yeah, we are now actually also discussing that and we are hoping, and we did some suggestions to even improve the Solace platform in that area. So hopefully that will come soon. But in general, I think the good thing about Solace in that area is, and that's also what we learned, because you are often used to a certain way of working. But if you get new tooling, then you also get new ideas. You become also, or you have to become creative. And for example, the way we retry messages now versus, let's say, 1 to 2 years ago is actually even more flexible than we were used to. We were used to manually retry stuff, push it to the support guys, but we can now automate that by scheduling, for example, automatic retries and a kind of auto fix kind of integration process. And depending on, let's say, properties we can set, and depending on even, let's say, properties we can set dynamically during the integration processes. So that makes it even more flexible. So that's nice. Yeah, but it was a challenge initially. It pushed us in a different direction, and I mean, but in the end, it works well.
Right. No, that's great. And I remember you had a lot of interactions on our Solace community as well, asking questions back and forth. Just a quick to show the audience members here on the Solace community, we have a couple of people interacting. So if you go ahead and search for Boomi, you will see a bunch of questions, a bunch of different suggestions. You see here Sjaak asking questions on the Solace community as well. So it is available here. We do have a question from the audience, and this is something that we could put on the screen. We'll see if we could answer it. VKS asked on YouTube, he was like, the Solace Boomi connector allows you to consume events from a DMQ on a scheduled basis.
Yes, you are.
So the answer is yes.
Yes, the answer is yes. And that's actually what I showed you in the example. So for example, you can build a process, a scheduled process, just get the messages from a dead message queue and push them to, let's say, what we do to the original queue, or whatever you want to do with those messages. So
okay, no, this is perfect. Thanks for this talk and demo and your overview on how you used the Solace PubSub Plus connector as well within Boomi. To anyone who's watching live, Sjaak is the CTO and co-founder of Appronto. You can follow Appronto on Twitter at Appronto. You can check it out here. As we get more people in, if you guys have any questions, feel free to ask them on the chat window. Sjaak is hanging around to see if there's any questions to be answered. But if you have any other questions that you want to ask, feel free to also join the Solace community and ask your questions there. So that's about it for our first talk. Sjaak, thank you very much. Do you have any last things you wanted to say or talk about?
Well, just use Solace in combination with Boomi and you will be happy. That's all I can say. So
okay. Perfect. Well, thank you very much. Really appreciate your talk into this. Next, we do have Laurent from Microcks. I want to remind people, or like whoever is joining us right now, feel free to ask questions in the chat. Let us know where you're joining us from. So if you just joined, if you got into the chat window, please let us know where you're joining us from. I'm super interested to know where in the world people are joining us from. So time being, we'll take a quick intermission and we will have Laurent next. Sjaak, thank you very much. And
all right, you're welcome.
We'll see you in the next Lightning Talk.
We will. Okay, thank you.
All right, so now I'm ready for our next talk. We're going to be introducing Laurent from Microcks. Just a quick intro and background about Laurent. Laurent is a cloud native architect and he works during the day at Red Hat. He is Microcks' co-founder and he helps organizations adopt distributed and cloud paradigms. He is the founder and developer, as I mentioned, in Microcks, which is an open source project based on, it's a Kubernetes native tool for API mocking and testing. For this, while he built Microcks, he used his 10+ years extensive experience in the financial services industry, where he defined API transformation strategies, including governance and delivery process. So right now, while Laurent has an extensive experience in several areas in tech, today we're going to focus on the Microcks aspect of his experience, and we can see how it can be used to accelerate EDA adoption. So without further ado, we're going to welcome Laurent to the screen. Laurent, welcome.
Hey. Hi,
How's it going?
How are you? Yeah, fine.
I'm doing
Just
well.
sunny today.
Sunny today. Where are you joining us from? Let us know where you're joining us
from France.
From France.
Yeah, it's the end of the afternoon right here.
Nice. Okay, that's great. Thanks again for taking part of the Solace Lightning Talks. I'm super excited for today's talk. I know you're going to be talking about kind of, accelerating EDA's adoption using Microcks and seeing like how we could discover the event structure and ensuring the quality of applications in EDA. Give us a little bit of background about, bit of intro about what you're going to be talking about before we jump into sharing your screen. And,
that's exactly the topic of today. So we'll go through some challenges we have identified when adopting event-driven architecture, and mostly challenges around communication, around the delivery process of this new architecture. And I will give you a short introduction of what is Microcks, maybe 4 to 5 minutes, something like that. And then we'll jump into a demonstration. It will be full hands-on so that you will see it in action, I would say.
Nice. Okay. Perfect. Okay. That is great. So feel free to share your screen. And again, to anyone who's joining us right now on Twitter and YouTube, let us know where you're joining us from. And if you have any questions, feel free to ask them in the chat. We are giving out some swag to interactive audience members. Laurent, if you have your screen ready, feel free to share it. Okay, I have it here. And I will share your screen in seconds.
So now,
right now. Okay.
Okay. Perfect. Perfect. Nice. So very happy to be here, and thanks a lot for the invitation. So just a brief introduction of what is Microcks. So it's a project I started some years ago, and it just reached the 1.3 release just before summer. As you say, it aims at providing an open source and Kubernetes-based tooling for API mocking and testing. We'll see in some minutes what it means exactly. We are an open source project. We welcome everyone to come, to share ideas, to contribute, also to give us stars on GitHub if you like it. And also, we want it to be purely community and users driven. This is really important for us. So we have users in financial services, as you said, coming from a background, and the roadmap is really driven by the users' feedback. So with Microcks, we decided to focus on and to tackle 3 specific concerns when dealing with APIs. The number one is how to shorten the feedback loop, because as API are now mainstream and they are becoming product, people are also adopting more and more agile methodology. So there is this concern about getting feedback very early in the project and be able to evaluate different changes. So this is the main driver. And the number 2 is about how to parallelize developments. Because once you have decided what is the API to develop, you absolutely want to avoid any bottleneck during the development. You especially do not want to have developers consuming APIs to wait for a backend to be ready, or having the team in charge of the microservice A to wait for microservices B and C for releasing their software. So it's really important. And the number 3 challenge is how to validate implementation. Because point is getting crucial. As an example, as you are releasing the version 2.1 of your API, you need to be sure that your implementation is compliant with the 2.1 contract. That's obvious, I would say. But also, if you respect the semantic versioning, you have to be sure that your implementation is still compliant with the 2.1 version, for example, 2.0 version, sorry. And we know that this could be tricky because it's usually very easy to introduce breaking changes. So the big differentiator with Microcks is that we are doing this with all kinds of APIs. So it could be REST API, legacy SOAP web services, and even now, of course, asynchronous and event-driven API. That's why we are here today. So today we realize that events and messages are everywhere because they are the ultimate weapon to decouple your components and your microservices within your architecture. We realize now that events bring a lot of benefits like space and time decoupling, resiliency, not blocking exchanges, also enhanced scalability. But we know that events also come with challenges because with their proliferation, it's become now crucial to treat them, as I said, first-class citizens like we do for the REST APIs. Otherwise, we are facing a lot of issues that puts us in this awkward situation. I really love this drawing. And we can face a lot of misunderstanding about the endpoint documentation. Think about medium to large organization when you have tens, thousands of topics. What is their goal? What can they be used for? There is also a lot of difficulties around the data format and how we can validate this data that is received through the different topics. And this situation is also due to delivery or quality issues. For example, because of the access to infrastructure. We know that deploying an event broker is not as easy as deploying an HTTP server. So during the test, it's maybe difficult sometimes to have access to a broker. Also, there is this problem of availability of events. We most of the time have to wait for someone to send event before we can start playing with them. And because of the communication patterns, the many-to-many communication patterns, sometimes it's also hard to ensure that the different producers are not sending garbage into the topic or the queue. So we want to check the data that is sent. We want to automate this conformance check the most possible.
You bring a good point here, Laurent, is that like to implement an event-driven architecture, it's not just about having an event broker or just having kind of that like middleman to do things. There's a lot more to event-driven architectures than just having the event broker, which is like documentation, governance, the validation of the events that's coming in and out. So the point behind EDA, there's a lot of moving parts into it, and it's important, at least for step one to a successful implementation of EDA or to a successful digital transformation journey, to having an EDA infrastructure in your organization, is to truly understand what is needed before going into it, basically.
Yes, the broker is just one thing, but we have to deal with a lot of satellite issues.
Right.
Yeah. So that's exactly what we want to do to address with Microcks and with the EDA support in Microcks. But how we are doing that? Microcks integrates into a design first and contract first approach, and we are using the syntactic elements of your contract. But more importantly, we take advantage of the examples you have provided within your contract, because often we neglect the importance of example. We let some tools generate them, and finally we have all the string properties having the value of string, or all the numbers properties having the value of 1, and so on. But we do think it's a best it's a best practice to pay great attention to the examples, because they should represent real life scenarios. And when they are carefully chosen, you can use them to translate business expectations, and thus you can later use them to execute as executable specifications. So basically, that's what we are doing with Microcks. We turn your examples into actionable simulations to realize mocking, and then we use them to realize testing, okay? And for doing that with event-driven API, event-driven architecture, we are leveraging the AsyncAPI specification so that you don't have to write some extra documentation or you don't have to write a script in order to do the simulation and the testing of your architecture, okay? But, speaking, it's time for demonstration.
Time for demos.
Time for demo, yes.
Perfect. Awesome. No, that's great.
Magic time. So the scenario today, we will start by writing a simple AsyncAPI specification to describe our event-driven architecture. Then we will import it into Microcks, and then we will see how Microcks can be used to simulate events using a Kafka broker, typically, so that your event consumers can start playing with your events even before writing your application. And then we will iterate on this because Microcks now supports multi-protocol bindings. So we are able to do the same things using MQTT broker, using WebSocket, for example. So we will do the same things, completing the AsyncAPI specification, okay? So let me switch my screen. Okay, so let's start by with AsyncAPI. If you don't know AsyncAPI, this is the sister specification of OpenAPI, but targeting event-driven architecture. So AsyncAPI allows you to describe your application in terms of channels, topics, queues, and the different messages that are published or subscribed to. And this AsyncAPI website has this nice playground. So you can start editing a new specification. So for example, here, this is the account service, okay, that is in charge of processing the signups of different users. And you may define a user signed up channel with a subscribe operation. That means that applications that want to use this API have to subscribe to this topic, and then they will receive the user signed up message. That is a simple message with a display name and an email address for the user. Pretty simple, okay? So once we have this skeleton, we can start adding some constraint. This is very important for doing the testing part. Okay, so let me, copy and paste. Okay, it's kind of buggy. And paste it here. Don't know why it's very slow once I have switched. Okay, so I want the display name property to be mandatory, as well as the email property, and I don't want any other additional property. Okay, that's the first part. Then I can add to my specification some binding information. So for example, I can explicitly tell that I want this API to be using a Kafka broker, okay, a Kafka queue. And finally, this is the important part for Microcks, I will add some examples to my specification just to give better illustration on how users are supposed to work with my API. So I can copy-paste a new example right here. So I may define static examples. This is the John example. And this is a recent addition into the AsyncAPI 2.1 specification. But I can also define random examples using this specific notation that is provided by Microcks. So I can specify just right here that I want a random full name for the display name and a random email address. Okay, so at that moment, we have something that seems correct. We can just download the specification.
Nice, and you're using, you're like, going through the specifications using the AsyncAPI playground. You made some modifications to the spec, and you can go ahead and download it from there.
Exactly. So
nice.
Just tell I want a Kafka binding, and I have specified some examples.
Perfect.
Okay, so, and now, oh, it's lagging a bit. I don't know why. It's the end of the day, maybe.
Yeah, maybe it's the
okay. So
StreamYard.
Maybe it's the streaming via StreamYard. I don't know. Okay, so let's switch to the Microcks UI. So I have a brand new Microcks instance. Okay, there is nothing in my repository. I can see there is 0 API or services right here. And once my AsyncAPI file will be unzipped, I will be able to import it into Microcks.
Right, and then now here, while this is processing, that's a good place, a good time to ask a question about the different protocols from a asynchronous standards perspective that are supported with Microcks. What are the protocols that are supported by Microcks, Laurent?
Yeah, so for the moment, with AsyncAPIs, we have the support of Kafka, of MQTT, and WebSocket. So these are the 3 protocols that are supported for the moment. Okay, so finally, it's pretty weird. Okay, so now I have the file at hand. I can just upload it within my Microcks instance. Microcks is also able to connect to a Git repository to refresh the definition and to have a always fresh definition. Right. And you can see that it has discovered the account service, that is an event API, and it has discovered that it has an operation also, and that it has a Kafka binding.
Nice.
And once it has discovered the Kafka binding, it has automatically created a Kafka topic for us on a connected broker, and it starts publishing messages each and every 3 seconds. Okay.
Nice.
So as a consumer of the API, I can now reuse this Kafka topic and just start playing with the messages. So let me start this simple consumer on the right. And you will see that once connected to the Kafka broker, I'm able to receive messages each and every 3 seconds, like my application was live, even if I did not write a single line of code. Okay? So this is the simulation part. So you start receiving messages as if the API was live. Okay?
Awesome.
You see the message?
Yeah. So this is great. So now you have your subscriber connected to the Kafka broker that your Microcks instance is publishing to mocks every 3 seconds on a frequency of 3 seconds each.
Exactly. So you can change these settings if you want a bigger frequency, if you want shorter frequency. That's highly configurable. So now I can do the same things, go back to my AsyncAPI specification. I can do the same things and add some other bindings. So for example, I can add the WebSockets binding, and this time this is a binding that takes place just at the channel definition and using the post HTTP method. And I can do the same things with the MQTT binding, that is a binding that takes place at the operation level. So
all you did was just make that modification in the spec, basically in the spec file, and then you could just download and re-import.
Exactly, because let's imagine you want to expose this API on different protocols and different brokers. So you have to add the different bindings. Okay.
Right. I do like as well, you mentioned earlier the GitHub repo integration in this, which really helps in either from a CI/CD perspective or making sure that you're up to date if you have this convention in your department or your team where you always keep your async specification up to date, and every time you update it on GitHub, on your GitHub repo, Microcks will automatically be triggered to import the new async API file, or like, query the new async API spec file and do the modifications on Microcks perspective, basically. Nice.
Exactly. So your mock repository is always up to date with your source of truth, that is Git, for example. So just as you update your mocks, it is updated in the second. Okay,
right.
So
before we going on the WebSocket demo, we do have a question coming in from YouTube. So someone is asking, where are we going to store these events, inside Kafka or any database? I'm not sure if this question is from like a Microcks perspective or just like in general, but let's see if you have any input on this, Laurent.
Yeah, so basically Microcks has his own database for keeping all the different service definitions.
Right.
And then after that, he is able to connect to any Kafka brokers, any Kafka distribution, any MQTT broker. So it's just a matter of configuration, and then it will publish the mock messages on the broker you have configured. Simply.
Okay.
Okay.
Oh, perfect. Thanks.
So just having a look on the updated definition, okay, you will see that now it has discovered that we have 3 available bindings, MQTT, Kafka, WebSocket, and it managed to create 3 different topics, endpoints, so that you can reuse and directly test on this other protocol. So nice. For example, if I copy-paste the WebSocket endpoint just right here and use this simple WebSocket client, I can connect, and you will see that I will receive, yes, new messages via WebSocket each and every 3 seconds. Okay?
Nice. No, this is
so
this is very
you did
cool.
not write so
yeah,
for the
zero
moment,
code. So
you did not write
you didn't really write any code.
Yes.
Yeah, correct.
It's just simulation, and then you may refine your specification to adapt to the feedback you may have.
Right.
Okay.
Right.
And just finishing with the second use case of Microcks, you can see that you can simulate, but you can also test your implementation. Okay.
Right.
You get this new test button right here. And for testing, so we need implementation. So imagine that some weeks later, now I have implemented the WebSocket protocol of this API specification. I have developed 2 implementations. I've got a good implementation. This is the green one. And you can see that I have a display name and an email address, like in the specification. And I have also deployed a bad implementation, that is the orange one. And this time you can see that I'm setting garbage. I'm not having a display name, but a full name. And I am having an additional property, that is the age. Okay, but I do not want any additional property. So the only thing I need is to get this address of the endpoint. Okay,
right.
Just put it here in the test endpoint,
and it will basically connect to that endpoint and subscribe to the topic of choice. Yeah.
Exactly. So you just give the URL, the WebSocket URL. You choose the runner, and you may choose the AsyncAPI schema runner, and basically it will connect to the remote endpoint, gather messages, and then check the messages against the AsyncAPI schema. Okay.
Right.
So that way you will know if it's correct or not. So in this case, this is not correct. And you can see that we have some validation errors.
Right, because you sent some garbage data
exactly.
Basically, that does not follow the schema that was in the AsyncAPI spec file.
Exactly. So we are able to do this with we are able to do this with WebSocket servers, but also with Kafka brokers, with MQTT brokers. So you are able to connect to any broker in your organization to periodically check if some applications are selling garbage or not.
Right, okay? Right. Quick question here: when you set up your test and you put your test endpoint, you just put only the URL of the endpoint. Is there a way where you can put a topic to subscribe to, or how does it know what channel or topic does it subscribe to, or is it depending on the AsyncAPI file?
No, you specify the topic within the URL. So here
within the URL, okay.
Yes, here I just have the WebSocket part that is for the topic, that is for the channel that I want to check. And this time, this is green because my green implementation is correct. So it's fairly easy to troubleshoot and to see the differences between different environments so that you are able to check your implementation. Okay.
Right. And in your demo, you showed it this working with Kafka. Does everything you're showing here with Kafka also work with MQTT from a broker perspective?
Exactly, and with any MQTT or Kafka broker distribution.
Right.
Okay.
Cool. Yeah.
As long as it is compliant with the standards, there is no problem. Okay.
Right.
Okay. Cool. So I think my time is up. I can just leave you with these two diagrams as a wrap up. Oops, sorry. Just
right.
Okay. These two diagrams summarize what we've seen today. The first use case is Microcks simulating from your API specification so that your API consumer can start working in seconds. And the second use case is about checking our API implementation is compliant with the contract. And of course, during the demo, we have done this through the UI, manually launching a test, but we provide anything you need to integrate this into your CI/CD pipeline. So you are totally able to automate all of this. Each and every time you deploy a new changes in your API implementation, you can check that you are not breaking the contract and you are still compliant with the spec. Right. Okay.
No, this is great. Thanks for this demo presentation, the presentation and the demo, Laurent. That was great. I know we had a couple questions from the audience, and it's awesome you answered some of them. Again, for anyone who's joining us right now on YouTube or Twitter, let us know if you have any questions. Let us know where you're joining us from as well. And to get to know more about Microcks, here is their GitHub repo, github.com Microcks/Microcks. And you can also follow Microcks on Twitter at Microcks.io. Perfect.
Exactly.
All right. Well, Laurent, that was great.
Thank you very much.
Very much for this. We do have a couple minutes before our next speaker. I did have a fun demo, like a little game that we put together with or animation we put together with Solace. Do you want to do it with me? We could just do a quick kind of like activity right now.
Yeah, of course.
Awesome. Okay, let's do it. So, Aaron from Solace, who's another developer advocate here at Solace, working on my team, put together a very cool demo that everybody could go check it out at sg.solace.com/QR. So I'm going to go ahead and navigate to this URL, and let's see it. So anyone as well who's live right now, even you, Laurent, you could go to this URL, and let's see what we can get and do with this. So as soon as you go to this website, you have a QR code. So Laurent, do you have a phone next to you?
Yeah.
All right, grab your phone and scan that QR code. Let's check it out.
Let's do that.
And anyone as well could do the same thing. So as soon as I scanned my QR code, I have my QR code. I just scanned it over here. Let's see. I'm gonna do this. I'm gonna go ahead and play around with this. So from my phone, just like playing around with the cube and interacting with it from kind of like an entanglement perspective. So you can go ahead and, you know, for fun, play around with it. So if you want to know what's happening here behind the scenes, it's actually a pretty cool demo. So like you can see over here, I'm actually like playing with the cube with my phone. But what's really happening behind the scene, and Aaron has a YouTube video about it. Basically, your phone is connected to through the QR code is connected to the Solace broker, and every time you execute a touch event on your phone, you are sending these events to a Solace broker. Now, the web browser app that you have on your phone is connected to Solace broker using WebSocket, and then using like the MQTT, sorry, it's the JavaScript MQTT protocol. And you can see here, there's kind of like different ways to send these messages. So I think that's a pretty cool quick demo to show how events are being sent in real time from your phone, from the web browser on your phone to a cloud Solace broker, and the browser application over here is a subscriber to these events. So your phone is publishing the events, and the browser is subscribing to these events. So you can see I'm like playing around with it as well from here. So excellent. Yeah, were you able to do it as well, Laurent, from your end?
Yeah, it works very well. Look.
Fantastic. Yeah, here, I'll check it out here. Yeah, oh, I see you have the broker. So what's really cool, I wanted to point something out here as well is, Laurent, you're in France, right? Exactly. And I am in North America. Behind the scenes, what is happening is we have 3 different brokers as well in different cloud versions. As soon as you log into the site, basically, what this does, I'm going to go ahead and refresh. So you'll see it's benchmarking. What's happening here is this web browser is trying to find the nearest Solace broker to you. So whether you're in Singapore or in Europe, UK, or in the US, and it connects to that broker based on some round trip time testing. So first of all, what would happen is we will subscribe to a QR timing topic, and then publish messages to these different brokers, all the different brokers, to see the shortest round trip time. So the broker that I am connected to is different than the broker that Laurent is connected to, depending on the round trip time. So you can see here right now, this is the Solace broker that I'm connected to based on my round trip time. So that's pretty much it. That's kind of the quick demo I wanted to show. Feel free to play around with it. If anybody has any questions, put it in the chat. And yeah, and that's about it for today. I wanted to have this quick demo. Awesome. Well, we have up next Dunith from WSO2. Laurent, thank you very much for joining us. We'll have a quick intermission, and Dunith behind the scenes will be getting ready for his talk. Yeah. All right, we'll talk later, Laurent.
See you later.
Thank you very much.
And do not hesitate if you have any question on the chat. No problem.
Perfect. All right.
Bye-bye.
See you later. Bye now.
See you.
Bye. All right, so we had the second talk for today. We're jumping into the third talk. Anyone who's joining us again live from YouTube or Twitter, please let us know where you're joining us from, what city, state, country. That would be great. And a quick reminder to everyone that You can ask any questions on the chat and join our Solace community. Without further ado, next we have Dunith, who is a lead solutions engineer at WSO2, which is an open source technology provider focusing on API management and enterprise integrations. Today, Dunith is going to be talking about the role of WSO2 in EDA and how different WSO2 product fit in the space. So I will go ahead and introduce Dunith to the stage. Hey, Dunith, how's it going?
Hi.
How are you?
Pretty good. I'm doing okay. Yeah.
That's great. That's great. I'm doing well. Thank you. I'm pretty excited for the first two talks. They were like great content, a lot of interaction as well, and it's cool to see the different technologies in the EDA space. So whether it's from the iPaaS perspective, where Sjaak talked about Boomi integrations, or from a mocking and management perspective that Laurent kind of like showed us from a Microcks point of view. And I'm excited to kind of like hear from you as well. Before we get started into who are you, what are you going to be talking about, what is going to be the intro of all these things, where are you joining us from?
Yeah, so I'm joining from Colombo, Sri Lanka.
Nice.
Right now it is 9:30.
Oh, it's 9:30 right now, yeah?
Yeah, it's 9:30. I'm
right.
half hours ahead of you. Yeah.
Okay. What do you have for today to speak about?
Yeah, so I came up with a small set of slides. So I'll talk about the different facets of event-driven architecture, because EDA is pretty much a loaded term these days. So we'll explore certain ways you can utilize event-driven architecture. For example, there are stream processing, streaming ATL, change data capture. So we'll have a look at each of these options, and I'll slowly introduce you to WSO2 products, different WSO2 products, and we'll see how they will work together to build certain scenarios. And
awesome.
Yeah, at the end, I have put together a small demo, so I'll show you how Streaming Integrator and WSO2 API Manager work together to create an asynchronous API.
Perfect.
Yeah.
Fantastic. If you have a set of slides, you can go ahead and share your screen. I will stream it into the stream, and then we could take it from there. We'll see if there's any questions as well from the audience as you speak. And if I have any questions as well, I will interrupt you, and we'll see what kind of things. So absolutely. I will go ahead and share your screen. Are you ready?
Yes.
Are you sure? I'm just kidding.
Yes.
All right, I'll put it on. Okay. Awesome. All right. So the stage is yours, Dunith.
Thanks, Dominic. Yeah. So in this talk, I'll briefly talk about the different phases of event-driven architecture and how you can use the different WSO2 products to address these kind of different event-driven use cases. Right. All right. So I put together a diagram so that we can start from the middle and we can talk through different scenarios and bring in different products. Right. All right. So, in a typical event-driven architecture, you can see event broker in the middle. So everything revolves around event broker. So this event broker can be a message broker like RabbitMQ, Solace PubSub Plus, or it can be even a event streaming platform like Apache Kafka, or even simply a web server that continuously streams out events over HTTP protocol. So, for example, you can include WebSockets, webhooks, and these kind of asynchronous protocols as well. And then we have event producers. So basically, producers are the folks that continuously publish events to this event broker. So these producers can be external to your organization, such as IoT devices, mobile applications, partner applications, and the list goes on. And they can also be internal applications that sit behind your corporate firewall. So that's event producers.
Right.
Then then the question comes, how do you expose how these producers get to know about what events available in your architecture, what are the APIs available there, and this is and that's a typical challenging typical event-driven architecture.
Right.
So today there are events with multiple different formats. Event broker information is already there. Everything is all over the places, right?
Right.
So like Laurent explained before, so there must be a centralized mechanism to document them and govern them in a centralized manner. So this is where async APIs like specifications come in handy. So,
right.
Right.
And like as you mentioned, it is a challenge existing in ADA, for example. Like, how do you expose broker details? If I'm a producer, how do I know what is the broker details I want to connect to, or what are the topics that I can publish to, basically?
Exactly. Yes.
Yeah.
So like you mentioned, so asynchronous API. So in that, there you can include your broker information and the credentials and the security schema you should use to connect. Also, your different API event channels like topics and queues. And most importantly, you should document all the schemas of the formats that goes into your event broker and comes out of your event broker as well. Right. So so once you have that information, you can create an async API with that information. So in that case, we can use WSO2 API Manager.
Right.
So WSO2 API Manager allows you to create an asynchronous event-driven API based out of an existing asynchronous async API specification. You can then you can securely expose your event broker to the outside audience through API gateway.
Okay.
And on top of that, you will get built-in value additions like built-in API security, like secure incoming events like OAuth2, OpenID, API key, like authentications.
Right.
And then you will get rate limiting and throttling so that you can avoid DDoS attacks when you are in production. Also, you can use a publicly facing documentation or developer portal so that you can advertise your asynchronous APIs in a publicly addressable manner. So right. Yeah. So once you have APIs, sorry,
go ahead.
APIs, sorry. Go ahead.
Continue. My question maybe would be a bit divergent to me.
Right. So once you have that asynchronous API listed in the developer portal, different event producers and event consumers, they can come there, they can discover different APIs, and they can go through the documentation and they can figure out how to connect to your event broker or event-driven application. So,
right. One of the common issues or situations that is faced in the real enterprise is legacy environments. So what if I have a legacy environment where I can't modify the existing system to produce events? How can I event enable that environment? Like, where does WSO2 fit in that architecture, basically?
Right, that's a good question. So yeah, that's a pretty common scenario in modern industry as well. So we have valuable insights locked up in traditional legacy systems, like mainframes, file systems, and traditional databases as well. So by using a combination of WSO2 enterprise integration products, you can extract this information, transform them, and you can build events out of that and send it to downstream consumers. So for example, you can use WSO2 microintegrator to periodically poll a remote SFTP site for new files. And if there are any, you can ingest the file content and you can raise an event, and so that you can notify your consumers that, hey, there's a new event, a new file available there, go do something with that. So that kind of thing you can do with microintegrator. And along with the same lines, you can use the change data capture or CDC features of WSO2 streaming integrator to capture row-level changes made to transactional database and propagate them as change events into downstream systems. In fact, we use this open source Debezium library as embedded mode within the streaming integrator.
Mm-hmm.
So yeah, you can see that products in this yellow color background, yellow color box over there.
Right.
Right.
Okay.
All right. Then we come to event consumption, right? So we talked about event production and the event documentation, the event broker, and finally we came to event consumption.
Nice.
So when it comes to event consumption, there are two strategies. So let me talk about the simple event processing here. So I'm going to talk about this light blue color box.
That's for the event consumption portion.
Exactly, yes.
Nice.
So in the first strategy, we use a simple event processing. That means you process only one event at a time. So basically, the past events don't influence the current events processing or the outcome of the current event. So that's the difference here. So for example, you receive an event from your broker and you apply some transformation to it and probably send it to downstream consumers so they can process that further. Or maybe you can update your database to reflect the state changes that happened in the upstream components.
Mm-hmm.
Right. Then maybe you can kick off an event-driven workflow running in a different machine. So
right.
That sort of stateless event processing scenarios you can do with micro-integrator.
Okay, and is this where like you can do, like if you have a stream of events to be processed, is this where you can do like complex aggregations on them? And if that's the case, like what kind of aggregations you can do on the stream?
Right. So then we can talk about event stream processing. So that is where I can talk about streaming integrator. So this is where
okay.
Right. So if you process one event at a time, you can use micro integrator.
And is that the micro integrator where you could do complex aggregations to it? Could you also do kind of, let's say if one of the process or one of the aggregations I want to do on the data is moving it from one place to another, like is this something that you can use the streaming integrator for, let's say, an ETL pipeline? If you have some sort of an ETL pipeline, you want to do complex aggregations on the data and also move it from one place to another. Is this something that is kind of doable within the WSO2 architecture and like tooling?
Absolutely. So like you said, so you can use streaming integrator. So that is the purpose-built product to address these kind of issues. So speaking of stateful event processing, you can use streaming integrators built-in C language to process these kind of stateful operations. For example, you can ingest a stream of events from a Kafka topic and apply a sort of stateful operations on top of that stream. For example, we can do operations like joins. We can join multiple events together and produce one denormalized stream like this. Also, we can do window operations and aggregations like, for example, we can do sliding windows and tumbling windows with streaming integrator. To make it simple, let's say you want to count the number of events passed within last 5 seconds. Right? So what you do is you write a window query using CT, and you can do an aggregation like count. And if the count exceeds a certain threshold, you can perform some sort of a action, or we call it a side effect. You can raise an alarm, right?
Okay.
So yeah, pretty much these kind of stuff you can do applicable to real-time fraud detection, then real-time model training, and maintaining low latency dashboards and so on.
That is true neat.
Yeah, and also I think talking about streaming ETL, streaming integrator can be used to build real-time data pipelines where they always listen for incoming events and they can deliver to different destinations
Right.
in real time.
Right. No, that's pretty neat. So like you pretty much talked about, from a WSO2 perspective, the products where event production fits in, event consumption fits in. If you want to do complex aggregations or real-time ETL pipelines as well, it could all fit in from the specific products. So like if I want to have, let's say, if I want to tie it all in, to get the bigger picture and overall kind of use case, let's say if I have a streaming data source, if I have an MQTT broker streaming events on an MQTT topic, what is the best way to expose it to consumers? Like if I just want to have kind of the general implementation, I have the broker, I have a streaming data source, how can I expose it to consumers?
Right. So that's a good question again. So in that case, we can use a combination of WSO2 API Manager and Streaming Integrator to expose your streaming data source to the outside world in a secure and regulated manner. So the first step is to create an asynchronous event-driven API in the API Manager so that you can document your API and you can advertise it to the general public so that developers can come there and they can consume and they can read the documentation and try out that. And at the same time, you can implement your streaming backend with streaming integrator.
Right.
For example, you can consume this MQTT event stream from streaming integrator within streaming integrator. So you can maybe use event broker like Solace PubSub because it has this MQTT protocol.
Right.
So you can consume from event streaming integrator, then write to WebSocket channel or something like a server-sent event source, or maybe push it to a webhook or something applicable. So that way you can bridge the gap between these two data sources. So when someone publishes an event to an MQTT broker, it will end up in as a WebSocket someone else's browser. Right. Okay,
that's that is a pretty neat kind of from a use case perspective and all the different tools and the products under the WSO2 umbrella, basically, that is related to event-driven architectures.
Exactly.
Fantastic.
So, right. So just to recap what we have discussed, so here's the gist of it. So basically we have three major products to help you build different event-driven applications. So it starts from API Manager that allows you to manage both synchronous and asynchronous API in one place with built-in advantages like API security, rate limiting, public-facing developer portal, analytics, monetization, and so on. This goes on. Right? Then, if you have simple event processing and event-enabling scenarios, and probably enterprise messaging as well, you can use micro integrator for that. And then we have streaming integrator to address stateful stream processing scenarios. Something like pattern detection, complex aggregation, like you said, and also we can use the change data capture features to address these kind of problems.
Nice.
Streaming ETL.
Nice. And that is that is pretty neat. And a common theme as well from what you're talking about, and what Laurent was talking about as well earlier, is from an API management perspective. So the API management is at the heart of any digital transformation management. Like you have to have a solution or a strategy for your API management. And from a market perspective, the API management market is even growing. It's currently at a $4 billion+ market from an API management perspective. That goes to show how important it is to have an API management strategy if you're planning to have a digital transformation strategy as well for your organization or for your product. So this heart goes to show how important it is to have an API management strategy, and just unifying this API management across your synchronous and asynchronous APIs. Like there has been a lot of tooling and solutions and strategies for API management in the synchronous world. If you're using your REST synchronous APIs, it's kind of like API management solutions. But it's more important than ever right now as asynchronous communication starts to grow, as digital transformation starts to happen, and as people start to realize that event-driven architectures are really important, having a unified API management strategy across your synchronous and asynchronous APIs is kind of like, how can I offer all my APIs within the same developer portal? You have a developer portal for your API management. You have to find a way to merge the gap and connect between your synchronous and asynchronous APIs.
Exactly. So we as consumers, information consumers, we crave for real-time data, right? So we would like to get real-time notification on our phone, and we don't like to poll a website, right?
Right.
And due to that, so there's a increasing demand for real-time APIs, so event-driven APIs. And the problem with the current or traditional architecture is we have event brokers reside in the corporate firewall. So that is not web friendly. So there's a gap. So that gap has to be bridged by putting an API layer, API management solution in the middle. So that is what we do with asynchronous APIs.
Awesome.
Right. So yeah. So all right. So I've been talking a lot. So let me put together a small demo. So in this demo, I'll show you how these two products work hand in hand to deliver a real-world scenario. So I have a small scenario. I have a small use case prepared. So basically, I have a local WebSocket server running in my local machine, and then what I did was I created a managed API in the API manager to expose this API as a synchronous API. Then in this demo, I think myself as a developer from a third-party organization, and I log into the developer portal, create an O2 application, and subscribe to this API and start using it with my WSCat utility. So if you're not familiar with WSCat, it's a simple command line utility you can use to invoke WebSocket-based APIs. All right. So then finally, we have a streaming integrator. So I'm going to use it to mock a simple stream of notification that can be published to the WebSocket server. So at the end of the day, the consumer should be able to see a stream of notifications appearing in the WSCat. All right, let's get started. All right, so here you can see WSO2 API publisher. So for this, for the interest of time, I have already created this notifications API. But if you are starting from the scratch, you can always go to create API, and you can go to streaming API, and you can select whatever the technology you are interested in. Currently, it is supported for WebSockets, webhooks, and server-sent events. Also, if you have any already existing asynchronous API definition, you can import into API Manager so that you can generate an API out of it. So for this demo, I have this notifications API. Let's see how it looks like. So here you can see the metadata. You can see especially the endpoints. You can see I'm exposing my local WebSocket server in production and sandbox endpoint. Also, you can notice these topics over here. So basically, these topics correspond to event channels in the Async API specification. So in my use case, I only have one channel or one topic, that is notifications, which means I'm telling my consumer, hey, I have this channel and it is of type sub. That means you, as a consumer, you should subscribe to my API, and these are the type of payload properties you should use, and this is the URL mapping, and so on. So right now it is already in place. if you switch to this AsyncAPI definition, you can see the corresponding AsyncAPI has been generated. So you can see the endpoint as well.
Nice.
Right. And if you look into this lifecycle state, currently it is in published state. That means it is publicly accessible in the developer portal. So that means it's running in production. But if you want to transition the lifecycle state, you can do it through this lifecycle management. So that is one important aspect we see in a typical API management solution. All right, so now we have our API in place. Let's go see that in the developer portal. All right, so this is our developer portal, which is also coming from the WSO2 API manager. So here you can see a catalog of all your synchronous and synchronous APIs as a API catalog in a central place. You can see, click on this notification. So in this case, just imagine I'm a third-party developer coming from another organization. So I'm interested in consuming this notifications API. So the first thing I need to do is just to play around with it, right? So I need to see the documentation, how the definition should looks like, what are the available channels, where to find the event broker. So these kind of definitions I can see by going through this developer portal. And then what I'm going to do is I'm going to create a new application, OAuth2 application, to subscribe to this API. So that's a pretty much the standard of OAuth2. So you usually subscribe to API through an application. So to do that, you can click on this subscription and key generation wizard. You can give your application the name by left. You can optionally select a quota. For example, this quota is it's like a policy where you can control the rate limiting or throttling for specific application.
Right.
All right, then I can select the business plan. So there's one thing I forgot to mention. So whenever you are publishing an API, there's the option to select the business plan along with your API. That means you can attach a rate limiting policy towards your API. So that means you can virtually limit your consumers from doing DDoS attacks. Right. So whenever they reach their quota, they'll be throttled out from this API. All right, let me generate a new token. I'm just copying and pasting it here for later use.
Right.
All right, now you can see the newly created mobile application has been added in my subscription. So right. So next, what can I do? So as a consumer, the next step I can do is to now I have consumer key and consumer secret. Now I can go ahead and invoke my API. Right. So for that, I don't know how to invoke that API. So let me see. This tryout feature will help me figure it out. Right. So in this tryout window, you can see what are the available servers. So this is my backend. So in this here, you can see the actual command I should use. So I'm gonna use. I can also see that in the documentation as well. So what I'm gonna do is So you can put any kind of documentation. You can attach any kind of documentation to your API, like quick start guide, SDKs, and so that you can increase the onboarding time of your developers. Right. So then I'll quickly replace this API.
For the token you have, yeah.
Exactly. So this is just a placeholder. Right.
Perfect. Yeah.
So if you look at the command, so it says wscat c. That means you should connect to make a connection to this WebSocket endpoint.
Yeah.
And this is the bearer token I should pass to
Right.
API.
Right.
So when API manager receives that,
Mm-hmm.
make sure that I'm a legitimate consumer. So that
Okay.
it allows me to receive events. All right. So now I'm subscribed and listening for incoming events.
Mm-hmm.
Right. So where's the data now? So that's the next problem. So for that, I have a mock streaming integrator server service.
Right.
So it is running in the behind. So basically what it does is, so here you can see the application, real-time application logic written in the CTO programming language. And
Mm-hmm.
this is how we write a real-time streaming application. So this is
Right.
pretty much similar to, you can see standard SQL. So what I have done here is I created the event stream to represent an incoming stream of notifications.
Mm-hmm.
So
Mm-hmm.
here I'm just going to mock it with my simulator tool. But in a real world use case, you can read from a Kafka topic or MQTT broker like Solace, and you can write it to a WebSocket.
Mm-hmm.
So this is where I define my WebSocket channel. So this is the exact my local backend. Right here, I just wrote a simple SQL query, something like that. So to read from notifications and insert into WebSockets.
Mm-hmm.
Right. Okay. Now I'm going to simulate a message.
And through this, you're just kind of like simulating the message
Exactly.
using the streaming integrator. Yeah.
Exactly. All right. So here we see, not sure that you can see it. Let me zoom in. You got your message.
Nice.
Say message hello, and we can send another one. Let's see.
And then you could just
Right.
see that in
Yeah.
in your
Right.
consumer. No, this is interesting. And here, as you mentioned, you used like multiple WSO2 products as well. For the sake of time, I do have a lot of questions, and I do want to kind of like elaborate on a couple things from the demo perspective. But I will save it for later. I do know that if any of the audience is also asking questions, they could definitely ask it on the Solace community. So with this, Dunith, I want to, so here you can see everyone in the ticker down below. This is Dunith's Twitter. Definitely feel free to connect with him. But overall, just kind of to wrap this up, you kind of went over the different products with WSO2, how they can be used to define your event-driven architecture and also integrate a streaming aspect of things. Basically.
Exactly.
Dunith, if anybody wants to know more about WSO2 or have any questions for your demo, the things that you presented, what's the best way to reach out for you?
Yeah, so I'll be hanging around in this session. So feel free to post your question in the chat. Also, you can also reach out to me on LinkedIn or Twitter. So
okay,
it is in the ticker. So
yeah,
anyway, I'll be always there. Right.
Okay.
Perfect. Thanks for having me, and thanks for the opportunity.
Yeah, no worries. Thanks for being part of the Solace Community Lightning Talks. And stay tuned. I'll reach out to you after the talks for a good prize. There seems to be some police outside. But anyways, I'll take a quick intermission, and we'll go for our next speakers. We have Ahmed and Dennis talking about KEDA, which is a very cool demo. Stay tuned. All right. Thank you.
Thank you.
Bye. All right, everyone, we are coming towards the last talk for today's Solace Community Lightning Talks. We've had great talks today from Sjaak from Appronto talking about Solace PubSub Plus in Boomi. We had Laurent from Microcks talking about the powers of Microcks in event-driven architectures. And then we had Dunith from WSO2 talking about the importance of API management in EDA as well. And lastly, today we're going to be introducing to the stage two speakers. We have Ahmed, a principal software engineer at Microsoft, and Dennis from Solace, who will be talking about event-driven autoscaling on Kubernetes using KEDA. So if anybody's using Kubernetes or have worked with KEDA before, there's very cool demo and content coming up. So without further ado, I'm going to introduce our two speakers for today, Ahmed and Dennis. How's it going, guys? How's everything?
Good. Yeah.
Doing well.
Great. Thanks for joining us. And I am pretty excited for the content of your talk today and the demo, because there's a lot of cool different things you can do with Kubernetes or autoscaling, and then having that kind of use case from a Solace perspective. Before delving into the heart of the talk, quick intro. Ahmed, where are you joining us from, and what do you do?
Yeah, hi. I'm joining you from Seattle, Washington.
Nice. We're like an hour and a half away, almost 2 hours away from Vancouver.
Yeah. Yes. Yeah, I work for Microsoft. I'm software engineer. I'm also one of the core maintainers on KEDA, which is a CNCF incubation project now. So yeah.
Nice. And Dennis, quick intro on where you're joining us from, please.
Thanks. I am joining you from central Pennsylvania, so a couple hours south of Toronto, where most of you guys are located. I've been with Solace since April, and picked up KEDA as one of my first responsibilities here with Solace.
Nice.
So I am an architect reporting up to the CTO group, just like you.
Awesome. Great. Yes, Dennis and I are in the same team. So I know, Ahmed, you have a couple slides. Dennis, you have a couple demos. So Ahmed, feel free to share your screen. I see your screen is being shared, so we can go ahead and kickstart this. So the stage is yours. Go ahead.
Right. So KEDA. First, to begin, what is KEDA? KEDA is an event-driven autoscaler for Kubernetes. What does that mean? Events come from a whole bunch of different projects. They could be event brokers like Kafka or RabbitMQ, but it could also be really any data store that has a record that you're interested in or you're interested in scaling in. KEDA itself supports a lot of different scalars. As you can see, those are just some of the scalars or some of the event sources that KEDA supports. And essentially, the way KEDA works is that you run KEDA in your Kubernetes cluster, and you define that you want to scale your application based on values or records or events that are coming from one of these data sources. What KEDA does is it goes and queries these data sources, and based on the result of a particular query, that could be, for example, a SQL query in the case of MySQL, or it could be the length of a queue or the number of messages on a topic. Any of that, any client, as long as there is a client for the data store, KEDA could query that data store and then take a decision to scale your Kubernetes resource. KEDA supports any resource in Kubernetes that has the scale sub resource. For example, those are things like deployment, stateful sets, but it could also be any custom resource that just implements the scale sub resource. KEDA also has special support for jobs in Kubernetes. So for example, if you want to spin up a number of jobs based on the size of an event or the number of events in one of your event brokers, KEDA could also do that. So how does KEDA link these two together? It does that using a custom resource definition called a scaled object. So if you think of your deployment that looks something like this deployment here on the left, for example, I have here a billing processor that maybe I don't need to be running all the time because people submit people pay their bills at the end of the month. So it only really needs to run or be active when there are records in our database that need to be processed. So you deploy your deployment scale to 0, and then you create a skilled object for it that looks something like this. It references the deployment here. By default, when you reference a name just like that, it assumes it's a deployment. If it's any other type, you just need to specify the API version and the kind here. And as long as it implements the skill sub-resource, KEDA will know how to talk to it. Oops. In your skilled object, you get to define a bunch of values here. These are things like what is your minimum number of replicas that you want to run on. And for example, in this example here, it's 0. So if there are no events in my event source, I want my deployment to be scaled to 0. You get to define your maximum, how many replicas you want that deployment to run on as max. You also get to define the polling interval, which is how frequently KEDA will go and check these event sources, and the cooldown period, which tells KEDA after the event source is no longer active, like you no longer have messages on the queue or records in your database or anything, how long should we wait before we scale down to 0? The event sources themselves are defined as a list. For example, here I only have one event source, which is Postgres, and I'm telling it to run this query every that many seconds, and based on the result of that query, scale my deployment. The final thing to notice here, or actually the one before the final, is the connection. So every event source is going to have some different secrets that need to connect, that you need to connect to that event source. For example, here, because this is a database, you have a connection string. Normally, the deployment that you're scaling will have access to that connection. So we have this convention called from env, which tells KEDA to take this value and resolve it from the environment of that you're trying to scale. If you don't want to use that and you just want to use secrets and you want to reference a secret, you can also do that. So you can point to a secret that contains these values. And that's it. Essentially, KEDA defines a whole bunch of different scalars. Each scalar has a very simple interface. It gets the metadata, and it needs to expose 2 functions that allows KEDA to query for the value of the metric that scalar is watching. How does KEDA determine then how to scale from, so that's how it activates the deployment. Like, let's say you have a bunch of records, it knows that it needs to scale your deployment from 0 to 1. But how does it calculate how many replicas to give your deployment? KEDA actually doesn't do that calculation. It integrates with HPA, or horizontal pod autoscaler, which is part of Kubernetes. So if you've ever defined an autoscale rule using HPA in Kubernetes, that's what you're using. By default in Kubernetes, that allows you to scale on built-in metrics, things like CPU and memory. But it also has this other thing called external metric, where you could define a metric server, and the Kubernetes API server will query the values of the metrics from that server and take scaling decision based on that. And that's what KEDA uses. So when you define that skilled object, KEDA will go and define an HPA for you, and then provide Kubernetes with the actual values of the metrics. So if you look here, there is this thing called target query, which exists in every scalar. That becomes your HPA desired metric value. And using this formula, HPA decides how many new replicas to add to your deployment or stateful set or whatever you have. And that allows KEDA to not just be able to scale based on external events like Kafka or SQS or any sort of external event, but also allows you to scale based on CPU and memory as well. So you could say, I want to scale based on this external event and CPU and memory, and you get sort of the combined scaling of all of these metrics. In terms of KEDA architecture itself, this is the architectural diagram that we have on the KEDA website. It can be a bit confusing to kind of just look at that diagram. So let's try to sort of break it down a bit. So you have KEDA itself, which runs a metrics adapter or a metrics server. That's the part that the API server can query for metrics. And it runs a controller, which is, which is talking to the API server. Whenever you create a new skilled object, it watches that and gets the new skilled object. It goes and defines an HPA for it and exposes the metrics server, and then goes and starts checking the event source based on the timer that you specified. Once there is an event, like there's a value in the event source, like we need to scale, KEDA itself will go scale the deployment from 0 to 1, and then rely on the API server or on Kubernetes to keep querying the value of the metrics so that it decides how much to scale it based on your max that you have specified, which is the 1-to-n scenario that we have here. So this is basically the architecture of KEDA and how it works. In terms of defining new scalars, it's actually like a really simple process. You just need to get a name. For example, this is the scalar that Dennis added for Solace PubSub Plus. And it has a name, it has a type, which is Solace event queue, and a list of metadata that's specific to that event source, as you can see from the names here. And that allows KEDA to now, and that was just released in the latest KEDA release that went out a couple of weeks ago. And if you define that scaled object, then you can scale your deployment from 0 to n based on events in your Solace PubSub Plus queue. I'm going to hand over to Dennis now for a demo, unless anybody has any questions.
I'm looking at the questions as well on YouTube to see if anything is coming on YouTube or Twitter. But so far, we don't have any questions. You went over kind of the KEDA overview, the KEDA architecture, and I know that Dennis has a demo and kind of like a architecture diagram there. So we can jump into the demo, and if there's any questions, I will chime in and interrupt you both and tell you kind of like, we'll ask the question and interact. So Dennis, the stage is yours. I know you have your screen shared, so I'll go ahead and share your screen whenever you're ready. Thumbs up?
Yep, we're all
okay.
set now.
Perfect. All right, so the stage is yours, Dennis.
All right, thank you very much, Tamimi. Okay, so the configuration that Ahmed was just showing us was for the Solace PubSub Plus scalar that's been incorporated into KEDA. So what that implies is that we can use KEDA to scale applications within Kubernetes that are reading from a Solace PubSub Plus broker. So specifically, we can scale on queue depth and message spool usage. So the way I'm going to run this demo is there's actually something here called a code lab, which code labs are just ways to introduce code or specific functionality so that developers can actually get their hands inside of it. So this is something that's actually available out here. So if I click on that guy, I'm going to show you what we're actually going to be doing here. So if you can see this diagram, is that clear enough for everybody? Hope so. This diagram will show that we have out here, there's a Solace PubSub Plus broker. This broker is hosting a set of queues. And then out here on our Kubernetes cluster, we have KEDA running, and then we have some consumers, termed here as microservices. So each one of these guys is reading from a specific queue. So in this case, for this demo, I'm taking a look at one of these where we have KEDA. KEDA will pull through the SEMP API, which is our RESTful API to see inside what's going on inside of our PubSub Plus broker. We'll be able to pull for the contents or the message length of a queue. And based on that, we'll be able to scale our application. In other words, create and destroy replicas based on how many messages there are on that queue, right? Make sense?
Right.
Okay, so
awesome.
Let's take a look at the configuration. So if you run through all these steps, and I'm not going to do that because I've already got everything here deployed. Mm-hmm. But if we take a look at the scaled object, so this is a version of the scaled object that Ahmed was referring to. This is kind of like the top down. Part of this is abbreviated right in here. I can get to that later if anybody has questions about it. But what this is showing is that we have the scaled object. It's pointing to a deployment called Solace Consumer. We're going to pull the SEMP API. In other words, we're going to look for the message, how many messages we have on the queue every 5 seconds. Here's our min replica count, max. So we can have 0 replicas. We can have up to 10 based on how many. Mm-hmm. Mm-hmm. And down here, this is the trigger definition. So this is pointing to the actual Solace scalar. So this is code that's actually embedded within KEDA. So if you deploy KEDA in your system, after I think the beginning of August, this will be included. You will be able to use this effectively out of the box. So this is pointing to our Solace SEMP API. This is something that's running out here in Kubernetes. And the Solace broker does not have to be installed in Kubernetes. It can be really anywhere. It's just, the KEDA has to be able to see it. So we have our message VPN, we have a queue, and these are called our target values. So with a value of 20, that means that once you exceed 20, if you have one replica and you exceed 20, it's going to want to go up to two replicas. So this is again, this is just the configuration. We can, if there are questions about that, we can I guess address that towards the end of the demo.
Right, and I did put the link to where this code lab is available. So to anyone who's watching us right now, what Dennis is showing is a tutorial code lab that shows you how to set up your environment, configure the setup to get KEDA up and running, and you can see it on the link below. So Dennis,
right.
Back to you.
Alrighty, thank you. So the next thing I'm going to do is I'm actually going to move this thing off my screen here because it's going to take up too much space. But I'm going to take and run a couple of commands. So the first thing that I'm going to do is I'm going to run a watch on Kubernetes just so that we can see the consumers. So if I run this guy, and looks like my connection went stale, but you can see down here that I have the Solace consumer is running, and this is giving me my account. This is the number of active consumers, and then this is or replicas, and this is the number of desired. So what I'm going to do next is I'm going to come over here to this other window, and I'm going to apply the scaled object that we just saw. So this is actually available as a URL. But when I apply that guy, it's going to create the scaled object on the Kubernetes cluster. And
nice.
like Ahmed said, it will actually create the HPA instance, and then it will target. It will say, okay, well, there are no messages on my queue, therefore I'm going to scale this application down to 0. So if I take a look at this guy. Now, my total number of replicas is 0 out of 0. In other words, I have zero replicas and 0 desired replicas. And I don't need any replicas right now because there are no messages on the queue. So
right.
If we take a look then at, if we actually write some messages onto the queue, which I'm going to do, there's a long, complicated command, but it's not that complicated when you think about it, but it'll be complicated to type it out. So I'm going to write a total of 400 messages at a rate of 50 messages per second onto my input queue.
Nice.
It's called scaled consumer Q1, right? So if I go ahead and execute that command, I'm going to start publishing messages. And as soon as that happens, boom, my number of desired replicas goes up to 1. Now I have 1 active replica out there. Now, as soon as the HPA or horizontal pod autoscaler takes over, it will say, oh, well, I have 400, and my target is X. So therefore, I need to have the correct number of replicas out there in order to process those messages. So it's going to go through. It's going to this consumer, just incidentally, is, I'm not sure if I mentioned this, it's reading at a rate of 1 message per second. So it's throttled. It's not like Right. It's going to try to read 400 messages instantly. So each one of these if I have 10 out there, it's going to read 10 messages per second. So it'll take a few seconds to get through that, but as soon as it does, it's going to identify that, hey, the backlog is no longer there, and it's going to scale down. So here it goes. So first iteration here went down to 5 replicas, and it should detect then that it's going to process through those, and presently it will go down to 1.
Nice.
And then so HPA takes it down to 1 replica, and then KEDA kicks in and says, because HPA is not capable of scaling to 0. KEDA itself, the agent, is what scales it to 0, but it's scaled all the way back down to 0 replicas after it went through the backlog.
Right. That's pretty neat to see that happening automagically, as I would like to say,
Right.
behind the scenes, where as soon as the load on your cluster is detected by KEDA, it automatically spins up different pods, and it does that event-driven autoscaling, basically Kubernetes
Exactly.
autoscaling. And it is truly event-driven by nature through different events coming into your system.
Right.
Nice.
So I think one thing, we don't really have time to do this, but there's also within the scaled object itself,
right,
which I showed earlier. And here, within the scaled object itself, I had this part ellipsized out. Towards the end of the code lab, it talks about modifying the HPA behavior. You can insert this section into here, which will allow you to adjust how quickly or how slowly that KEDA or the horizontal pod autoscaler will scale up and down. So, for example, like if your demand is going up and down, frequently, it's not doing what they call flapping, where it's trying to constantly just add and destroy pods. It will actually just smooth that out for you.
Right,
so,
right. A comment we got saying that like the KEDA trigger seems to be a bit more flexible, but there's a question coming in. Maybe Ahmed or Dennis could chime in this. What are the difference between KEDA and Knative eventing in general? If anybody has any comment to chime on this.
Yes, I can answer that one. So Knative is a bit more opinionated about how you manage your events. Essentially, you have to have a connector in Knative that understands your events, and then it converts these events into essentially HTTP invocation requests. So your application has to also understand, like you now are not talking to Kafka directly. You are configuring the Knative eventing connector to connect to Kafka and convert these into HTTP requests that then your application is handling, kind of how you do with Lambda in AWS. And that goes through Knative serving, and then scaling happens there. KEDA is very unopinionated about what you do inside your deployment. Essentially, you could be using Kafka SDKs or clients. You could be using whatever code that you have there inside your deployment. And KEDA itself is very unopinionated because you just tell it, I want to watch this event source, and I want to scale based on the number that comes from the event source. What you do inside your deployment, KEDA never really touches. So it's a lot more unopinionated in that sense. Does that make sense?
Yeah, makes sense to me. And hopefully, Laurent, if you have any follow-up questions on that, feel free to ask. He did have a comment saying that, from watching this demo, that the KEDA trigger seems to be more flexible from a trigger perspective. But
yes, and it's a lot simpler to define a new scaler for KEDA. Like, it's really simple. Essentially, you just have to have an SDK that the project doesn't go, so you have to have a Go SDK for your event source or some client that can talk to it. And as long as you can query that client, you can write a scaler. We also have an external scaler in KEDA, which KEDA could connect to any gRPC server that defines the same interface. So even if you, for example, have something that only has a Java SDK, you could define a Java gRPC server that exposes the same interface, and KEDA will just call it to that.
Right. Okay, let me see if there's any other questions coming into the screens right now. While I do that, Dennis and Ahmed, did you have anything else to continue on the demo or the talk you wanted to sprinkle on top before kind of like finalizing this?
No, I don't think so. I appreciate the time. Yep.
Yeah, if you want to try KEDA, you could go to the website keda.sh. Installing is very simple. It's just one helm command, and yeah.
Nice.
If you have any questions, we have a GitHub discussion part in KEDA. If you have questions or have any issues, you can use that. Nice.
And as you can see on the screen, the tutorial and the code lab that Dennis kind of like showed could be accessed on that website. And basically, there's an explanation of what KEDA is, a reference to KEDA.sh, the discussions on GitHub, and a way to kind of set up your environment. It's a very easy setup if you have your Helm charts all like configured and your Kubernetes cluster environment is done, so you could easily get it all configured and done. So I think that's about it. We're wrapping it up. That is the end our Solace Community Lightning Talks. We're wrapping it up on a good note with a great demo and great content from you guys. So thank you again for joining, and I appreciate any of the effort and the time put into coming into this. So Dennis and Ahmed, thank you very much for your presence.
Yeah, thank you.
All right,
Awesome. All right, have a good one, you guys.
All right, take care. Bye-bye.
So you guys, that is the end of the Solace Community Lightning Talks. As always, we have great discussions being continued on the Solace community. So feel free to go to solace.community and join our community there. Follow us on Twitter at Solace Devs. And we have a lot of great content, technical content, whether EDA related, Solace related, or anything else. And this is a shout out to all the Lightning Talks speakers. If anyone out there is interested to be part of the Solace Community Lightning Talks, please feel free to reach out or mention on the community. We're going to be doing these Lightning Talks on a regular basis, and that's about it. So as always, thanks to everyone who joined us, anyone who asked all these questions, and that's about it. Take care, everyone. Have a good day.